Hello everyone, this is Mr. Appel, and we're going to work through a problem like this where we're talking about area. So it says that I'm building a rectangular garden. So to start, I'm just going to sketch a rectangle. You can just label length and width, but I like to have a visual. Now, if I let's just say L represent the length and W represent the width. It says I have exactly 20 feet of fence material to enclose the garden. So what that means is L plus W plus L plus W, in other words, all the way around, has to add up to 20. So 2L plus 2W has to add up to 20. It also is saying that it's asking what dimensions give me the largest possible garden. So what the function we want to write is in terms of the area. So the area of this thing, the area of that garden, is going to be the length times the width. So similar to what we did in previous problems, let's move that out of the way. I have two variables and I want to just use one. And so I'm going to solve for W in terms of L. So I'm going to divide everything by 2, divide both sides of the equation by 2. So I have L plus W is 10. And then I'm going to subtract the L from both sides so that I can say that the width is 10 minus the length. And then I can do a little substitution there. So now I have area in terms of just one dimension. And again, it makes sense because if I tell you the length, let's just pretend that the length, I'm just going to make up a number. If the length was 2, going over to our figure here, then I know that this would be 2 and this would be 2, which would be 4. If I only have 20 feet of fence material, if those two make 4, if I subtract from 20, I'm left with 16, but those widths have to be the same, so they would have to be 8 and 8. So the idea again being that if you know one dimension, because of this constraint right here, you actually know the other thing. So you can write one in terms of the other, which is a big idea in algebra. So let's get those numbers out of there so we don't confuse you, because those were just made up. Okay, so now I have an equation for area, a function for area. I'm going to go ahead and put that in standard form. So that's 10 times L minus L squared, or negative L squared plus 10L. And so now I have a function that, given any length, will tell me the area. And so we want to maximize, because I'm trying to find the largest possible garden. So how do I find the maximum of a quadratic? Negative b over 2a. So negative b over 2a, which is negative 10 over negative 2, which is positive 5. And the variable here was L, so that's our length. So if the length is 5, the width is 10 minus the length, so that's 10 minus 5. I got that from over here. And so it's also 5. And so the dimensions then would be 5 feet by 5 feet. And so that would be the answer to that problem. And when you're writing it, you can write the two dimensions as 5, 5, or as 5 feet, 5 feet, 5 feet. Either way to write that answer is fine. Either one of those. Okay, that's all. Thanks.